Good afternoon. Today we're going to have a look at normal distribution. So this topic is very common at AS, A level, as well as even right through university. Okay, so I'm going to start by having a look at the properties. So in terms of the properties, it depends on the mean and the standard deviation. The normal distribution curve is also bell-shaped. Its function is continuous from negative infinity up to positive infinity. The curve is also symmetrical from the vertical line through the min. And lastly, since the normal distribution function is a probability function, the total area under the curve is 1. Now, one of the most important things that they will ask you in an exam is calculating the probability when you're given a question. So for today, we're going to have a look at two examples, example 1 and example 7. And then I'll upload the worksheet so that you can have a look at the example 2, 3, 4, 5, and 6 on your own. Now let us start. The length of a species of fish is normally distributed with a mean of 5.3 centimeters and a standard deviation of 2.5. A fish is selected at random. What is the probability that its length is less than 4.5? Okay, so the standard way when we're talking about normal distribution, we say x follows a normal distribution with the mean and the variance which is sigma squared. So in this case, we're going to say x follows a normal distribution and the mean is 5.3. And then the standard deviation is going to be, the variance is going to be 2.5 squared. Always note that the variance is sigma squared. So whatever standard deviation we're given, we say to the power of 2. Now we're going to find the probability of x being less than 4.5. So this is like the first step. This is the first step, and therefore this is the second step. So now this is going to be equal to the probability of x minus mu over sigma is less than 4.5 minus 5.3 over 2.5. Okay, so now we're going to have the probability of z being less than, if you punch this into your calculator, you get minus 0.32. Now, there's something that I need you to take note of. When we have the probability of capital Z being less than small z, this is equal to phi of z, right? So now this is going to be equal to the probability. This is going to be equal to phi of negative 0.32. Now, something that is also very important that you need to take note of is phi of negative z is equal to 1 minus phi of z. So while this is equal to 1 minus phi of 0.32, which is equal to 1 minus. Now, what is phi of 0.32? Right, so this is 0.62552. Let me just take you to the normal distribution table. This is your normal distribution table. We look for 0.32, and 0.32 is 0.62552. So now you're going to go on, and then you say 1 minus 0.62552. Okay, so 1 minus 0.62552, this gives you 0.374. I've just automatically rounded it off to 3 significant figures. Okay, now let us go on to B, greater than 6.4. So what is the probability that x is greater than 6.4? Now this is going to be equal to the probability of x minus mu over sigma being greater than 6.4 minus the min, by the way, is 5.3 and then sigma is 2.5. So now this is going to be equal to the probability of z being greater than 0.44. Now, there's something that I need you to take note of. When we have got the probability of z being greater than the small z, in this case, it's equal to 1 minus phi of the small z, right? It's very important that you take note of this. So now this is going to be 1 minus phi of 0.44. Okay, let us go on to the normal distribution table and check what would be phi of 0.44. Now, phi of 0.44 is 0.67003, right? Okay, so now you say 1 minus 0.67003. So 1 minus 0.67003, this is going to give you 0.32997. Remember, I have to round it off to three significant figures, so it ends up as 0.330. It also depends on what degree of accuracy does the examiner want you to use. Now let us go on to C. They want you to find the probability that the length is between 3.6 and 5.9 centimeters. Okay, so here's how you're going to do it. So to start with, please bear in mind that x follows a normal distribution with 5.3 as well as 2.5 squared being the variance. So we're now trying to find the probability that it lies between 3.6 and 5.9. Okay, so now we go on and then we say this is the probability of 3.6 minus 5.3 over 2.5. It's going to be less than x minus mu over the sigma, which is less than 5.9 minus 5.3 over 2.5. So this is equal to the probability of, let us punch it into the calculator, the probability of minus 0.68 being less than z, which is less than 0.24. Now, in this particular case, there's something that I need you to take note of, right? Something that I need you to take note of. If you've got the probability of z1 being less than z, which is less than z2, like what you can see over there, it's equal to phi of z2 minus phi of z1. So let us go on then. So now this is equal to phi of 0.24 minus phi of minus phi of minus 0.68. Now it then reduces to phi of 0.24 minus, what did we say about phi of a negative number? It becomes 1 minus phi of 0.68. So now this is phi of 0.24 minus 1 plus phi of 0.68. Now let us go to the normal distribution table. So in this case, what is phi of 0.24? Phi of 0.24 is 0.59483, right? And then we also need to find phi of 0.68. So phi of 0.68 is 0.75175. Okay, so let us go on and finish off the calculation. So now this is equal to 0.59483 minus 1 plus 0.75 175. Okay, let us just punch it into the calculator and check what we get. If you punch it all into the calculator, you get 0.36, 0.34658. Let us round it off to three significant figures. So it's 0.347. So this is correct to three significant figures. Now, let us go on to the last question, the last part under this one. So now they want us to find the probability between 2.8 and 4.9. Now for this one, I will actually ask you as the student to attempt it, and then maybe you can just write your answer in the comment section. So if you do attempt it, if you did attempt it, the answer is supposed to be 0.278. Let us go on to example 7. Let me just scroll down to it. Just a second, please. They said in a normal distribution, 7% of the items are under 35 and 89% of the items are under 63. Determine the mean and the variance of this distribution. Now, the probability of x being less than 35 is equal to 7. And then the probability of x being less than 63 is equal to 89. But here's the catch. We don't know what is the mean and we don't know what is the variance. So in this case, we're going to say the probability of z being less than 35 minus mu over sigma is equal to 0.07. I'm sorry, instead of writing 7, let us write it as 0.07, and instead of writing 89, let it be written as 0.89. Now, the probability of z being less than 63 minus mu over sigma is equal to 0.89. Now, what did we say if we have got the probability of z being less than z? It becomes phi of the small z, right? So we're now going to proceed then. So we'll now have phi of 35 minus mu over sigma is equal to 0.07. And then phi of 63 minus mu over sigma is equal to 0.89. Now, from here, how do we proceed then? You then say 35 minus mu over sigma is equal to arc phi of 0.07. And then 63 minus mu over sigma is equal to arc phi of 0.89. Let us proceed. So this is step number 3 and this is step number 4. Now, we then say 35 minus mu over sigma is equal to, now what is arc phi of 0.07? What is arc phi of 0.07? Let us go to our normal distribution table. Now, you look for a point, that is closest to 0.07. Now, in this particular case, it's going to be somewhere between this number and that number, right? So you then say the 0.07078 minus 0.07. And then you say the 0.07 minus 0.06944. In this case, you realize that the one that is closest is this one, which is at minus 1.48, right? So this is arc phi of 0.07 is minus 1.48. Now, let us proceed then. So we then go on to say 63 minus mu over sigma is equal to ACPHI of 0.89. Now, what is ACPHI of 0.89? Let us go to our normal distribution table and pick a point that seems seemingly closest to 0.89. It's somewhere between these points. Now, you realize that the one that is closest is the one with the smallest difference from 0.89, and it's at 1.23. So now this is going to be equal to 1.23. Let us proceed then. So we now have 35 minus mu is equal to minus 1.48 sigma. And then 63 minus mu is equal to 1.23 sigma. From here, you're going to use the simultaneous equation. I'll leave it to you as the student to do the simultaneous equation. But if you do it correctly, you're supposed to come up with your sigma being equal to 10.332 and then your mu being equal to 50.3. Okay, so basically this is all there is with regards to normal distribution. Thank you so much for getting to this part of the video. Okay, so I'm going to upload a link to SlideShare where I've shared the notes as well as the other remaining examples. Thank you so much for watching the video and do enjoy the rest of your day.